Question 18 from Active Maths 4, Book 2, page 375, question 18 on enlargements. Okay, so we're given this diagram here. We're told that triangle EFG is the image of triangle CDE, which is also the image of ABC under the same enlargement. Okay, so EFG has come from the enlargement of CDE, which has come from the enlargement of ABC. Right. Now, if they're all enlargements of each other, they're similar triangles, meaning that all their angles are the same. So the angle here is the same as the angle here, which is the same as the angle here. This angle is the same as this one, is the same as this one, and so on. Okay. It also means that all their sides are in the same ratio. So if triangles are similar, their sides are in the same ratio. So this side here corresponds to this side, which corresponds to this side. This side corresponds to this one, which corresponds to this one. All right. Okay, so the first part of the question is asking us to find the length of FG. So we're looking for the length of FG. So the first thing we're going to have to do is work out the scale factor. So I have to look at two sides that match up. So I can see my 7.2 and my 9 can come together. Now, because it's enlarging, I'm going to put the big one over the small one. So the scale factor is going to be CD over AB. So that's 9 over 7.2, which gives you 1.25, or 5 over 4. You can leave it as a fraction if you want. Now, that's my scale factor. So how am I going to get to FG? Well, if I enlarge BC to DE, then I can enlarge DE to FG. Okay? So BC multiplied by the scale factor of 1.25 will give me DE. And that multiplied by the scale factor of 1.25 should give me FG. Okay, so BC times 1.25 is 8 times 1.25, which gives me 10. So DE is 10, so 10 times 1.25 is going to give me 12.5. Now, part 2 asks us to find the length of BD. So I've just drawn out that separate triangle here. So I had 8, I had the angle of 60 degrees, and I had 9. And I'm missing a side. Okay, so if you're missing one side, and we have two sides and an angle, remember you can work your way through SOHCAHTOA, Pythagoras, sine rule, cos rule. So check in that order. I can't use Pythagoras here because I don't know that it's a 90-degree triangle, and it looks like it's not. Can't use SOHCAHTOA for the exact same reason. Because then I look at sine rule. Do I have two angles? No. Do I have two sides? Yeah, but I don't have two angles. So I need to be missing only one thing here. So if I was to do a line here, so I'm missing a side, but if I did another one here, I'm also missing an angle. Or if I did a line here, I'm still missing an angle. So I can only use sine rule if only one of those things is missing. So that means I'm moving on to cos rule. So cos rule is a squared equals b squared plus c squared minus 2bc cos a. All right, so A is going to be the side that's opposite the angle. So the angle I have is 60. So I'm going to use x here as my A in the formula. So that's going to give me x squared equals 8 squared plus 9 squared minus 2 times 8 times 9 cos of 60. Give me x squared equals 73. So x, the length of x, is root 73. Now, you were asked for that to 3 decimal places. So when you press SD on your calculator, you'll get 8.544 meters. All right, next you're asked to find the centre of enlargement for this. Okay, so the centre of enlargement, where did it all begin? So it would have begun somewhere way off here. And they said it begins at O. So we're just going to mark off an O somewhere. And I'm just going to draw that bottom line out. Okay, so I've drawn out this line here. O to B and B to D we've just found, so I can put that all in. Now, remember, everything should be, all the distances should be in the same scale factor. Okay, so O to B over O to D should still be within the same scale factor, okay? So again, we're going to go with the big over small because we know that that's what 1.25 is. So O to D should be x plus 8.544 all over O to B, which is just x, the distance we're looking for. And that's equal to 1.25. So now it's just an algebra question. Now we just need to do some cross multiplying and simplifying and solve for x. So multiply both sides by x and we get this. Bring your x's to one side and then divide by 0.25 and you'll get x equals 34.176 meters. All right, then part 4. Part 4, we're asked to check if the height of G from the ground exceeds 11.5 meters. Okay, the height of G from the ground. So the ground is here, so I want to check the height of this. This is what I need to find, the height of this. Okay, what do I know if this hits the ground? It's going to make a 90-degree angle. Okay, right, so let's look at what we have and what we could use. I now have a right angle triangle, meaning maybe Pythagoras or SOHCAHTOA could come in handy here. I've already found f to g. It was 1.25, no it wasn't, sorry, it was, what, 12.5? So we're going to mark that off. 12.5 is here. And I don't have this height and I don't have this length. So I can't use Pythagoras. So let's see, SOHCAHTOA, how could I use that? SOHCAHTOA, sine would tell me if I use this angle here, opposite over hypotenuse. Now, if I'm able to work out this angle, that should be able to happen. So how can I work out this angle? Well, remember, this angle is the same as this angle, which is the same as this angle. Now, we have already worked out what this side is. It's 8.544, so we'll write that in as well. 8.544. So we should be able to use this triangle to work out that angle here. Okay, so I'm just going to draw this out again. So we have 8.544, 8, 9, and 60 degrees. And we want to find this here. So I'll just call that A. Okay, angle A. So again, it's not a right angle triangle, so I can't use Pythagoras, I can't use SOHCAHTOA. Then I look at sine rule. Okay, I've got an angle across from a side, and I'm missing an angle across from a side. So there's only one thing missing, meaning I can use the sine rule. So remember, sine rule is sine of A over A is equal to sine B over B. So sine A is just going to still be sine A. That's opposite 9, so sine A over 9 should be equal to sine of 60 over 8.544. Alright, so sine of A then is going to be 9 times sine of 60 over 8.544. Now you can work that out if you want, or you can leave it like that for now and just say A is equal to the inverse sine of whatever that is. Pop that into your calculator and you will get, so inverse sine of 9 times sine of 60. Make sure it's in degree mode, your calculator, okay, because we're using degrees. So you should have a D here over, oops. Okay, we'll go again. Inverse sine of, put the fraction in first, 9 times sine of 60 over 8.544. Close up the bracket. You get 65.817. I'll round it off to 6 there degrees. Now I'm not going to round it off to like 1 decimal place yet because I don't want to have any rounding errors as we go. Okay, we'll try and keep it as accurate as possible. All right, so that's my angle. So remember now, that is the same as the angle here. So now I'm going to draw out that triangle. Right, so if we draw out this triangle, put it here. So we know that this here is 65.8176 degrees. We know that this is what we're looking for. We know that this is 12.5. So now I can use SOHCAHTOA. So sine of theta equals opposite over hypotenuse. So sine of my answer that I got here. Now you could just use the answer button to keep it even more accurate, which I will use, equals opposite is h over 12.5. So then to find h, we're just going to say 12.5 multiplied by sine of 65.8176. That will give us h. So 12.5 times sine, I'm just going to say of answer, and that gives us 11.4, 03 and so on. So we can round that off to 11.4 meters. Now the question asked us if it was going to exceed 11.5 meters, because then it wouldn't be okay, but it doesn't, so it is okay. So 11.4 meters is less than 11.5 meters, so it is within the construction guidelines. So its height is okay. Right.